Okay, I want to show you that relationship between the sequence of squares and the sequence of odd numbers. So the sequence of odd numbers, 1, 3, 5. The next number in that sequence is 7. After that, 9, so on and so forth. So when we look at a pattern like this with a sequence of numbers and then we extend it in this way, we're using what's called inductive reasoning, and we're doing mathematics. Sequence of squares, 1, 4, 9. Next number in that sequence, 16. Number after that, 25, so on and so forth. So this is 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. Now these two sequences are actually related. You can build this sequence right here, the sequence of squares, from the sequence of odd numbers. And I'm going to tell you about that by reading to you from the Book of Squares, written by the Italian mathematician Fibonacci in the year 1250. Here's a postage stamp with a little picture of Fibonacci on it. So in the very first paragraph of the Book of Squares, here's what Fibonacci says. I thought about the origin of all square numbers and discovered that they arise out of the increasing sequence of odd numbers. For the unity is a square, and from it is made the first square, namely 1. When Fibonacci talks about the unity, he means the number 1, and the first thing he says is the first odd number and the first square are the same thing. Then he says, to this unity is added 3, making the second square, namely 4. So if you add the first two odd numbers, 1 and 3, you get the second square, 4. Then he goes on to say if you add 5 to this sum, the next odd number, you get the third square, namely 9. So 1 plus 3 plus 5. Sure enough, 1 plus 3 is 4 plus 5 is 9. So if I add the first 3 odd numbers, I get the third square. Let's add the first 4 odd numbers. 1 plus 3 plus 5 plus 7. Okay, so I have 1 and 3 is 4, 5 is 9, plus 7, 16. I get the fourth square. And then one more time, 1 plus 3 plus 5 plus 7 plus 9. Sure enough, add these numbers up, what do you get? 25. So look what a great relationship this is. If I add the first 3 odd numbers, I get the third square. Add the first 4 odd numbers, fourth square. First 5 odd numbers, I get the fifth square. Using inductive reasoning, I don't even have to add the first 6 odd numbers. I know what it comes out to be. It's going to be 36. And sure enough, if you add the first 6 odd numbers, you'll get the sixth square, which is 36. So great relationship here between the sequence of odd numbers and sequence of squares, something that I really like. I see relationships like this and I think to myself, you know what, everything's okay. There's a pattern and connections to things in the universe that I might not see at first, but that it actually exists, and I can see it in the mathematics like this. So we see this relationship and we like it. And there's a second part to this too, and that is it sort of gives us a bond with Fibonacci. When Fibonacci writes about this relationship in his book, The Book of Squares, from the year 1250, we know what he was talking about. And also we have some idea of how he felt when he discovered this relationship. It's really a positive feeling. You like it when you see this, and Fibonacci probably did too. So it kind of gives us a bond with Fibonacci that travels through time. So in any case, here's the relationship between the sequence of odd numbers and the sequence of squares, something that I really like.